Hi all, it's the top of the hour. We'll give folks, as usual, just a minute to file in, but thank you for joining us. My name is Josh Hadro. I'm the Managing Director of the IIIF Consortium. I work with Glen, Robson, and Caitlin Perry as staff of the Consortium to support events like this and all the different community groups that you've been hearing about if you've been able to join us, and a lot of the work, like some of the things that you'll see in these upcoming lightning talks. So this is the last session for today. This is the final set of lightning talks. We have 5 to get through to play for you. I'll be playing them through my computer, and of course, as always, let me know in the chat if there's any issues with the streaming or the audio or anything like that. But yeah, in the meantime, just a big thank you to everyone who's joined us for these 2 days. We have one more day of material starting tomorrow with maps, the museums group, both presenting kind of the latest happening there. And then our final session ending tomorrow is kind of a roadmap and presentation of some of the strategic planning efforts that the IIIF Consortium has been undertaking. And so we want kind of community input and overall input into those things as we go into 2023. So let me get the elements set up here so that I can stream this correctly. Give me one moment. Make sure that I can share my audio as I'm doing this. And this is kind of the constant Zoom juggle, is finding the right, here we go, finding the right program and making sure that we're doing everything correctly. So you should be able to see the VLC screen. I'll start this. As I said, let me know in the chat if there's any issues. But to kick us off, we have Ruven Pillay talking, who is the maintainer of the IIPImage software library, the image server, also works for C2RMF, talking about some of the things that can be done using IIPImage. With that, here we go.
Hello, I'm Ruven Pillay. I'm a researcher working on imaging and data science at the C2RMF, which is the National Centre for Arts, Restoration and Research housed within the Louvre Museum in Paris. And I'm also maintainer of IIPImage, which is an open source image server which is compatible with IIIF. So the title of this lightning talk is IIIF Image API using IIPImage to simultaneously handle multiple API versions. So version 3 of the IIIF Image API was released in 2020, but uptake has been relatively slow. Many IIIF image repositories have not yet updated to version 3. Indeed, if we have a look at the IIIF.io website itself, there's a section with demos with various implementations of IIIF in action. If we take a look at the first one in more detail and use our browser's web developer tools to trace the requests and responses we get, if we have a look at the info.json file we get back from the IIIF server being used, we can see from the context field here that it's sending us back a version 2 image IIIF image API file. And indeed, if we look at the other demos on the site, all of them are also still using version 2 of the image API. So changes to the image API between versions 1 and 2 were incremental and backward compatible. However, version 3 made some breaking changes to the structure of the info.json file. Let's remind ourselves of the IIIF image API. Essentially, we have 2 parts: an image request syntax, which you're all familiar with, where you can define a region, an output size, a rotation, an output format. And there's also an info.json file which defines certain metadata necessary to use that image. So it defines the size of the image, tile sizes, these kinds of things. So IIIF repositories clearly need time to transition completely to version 3. The transition to version 3 of the image API is often linked to the transition to version 3 of the presentation API, making the whole process a bit slower. And as an open standard, a IIIF server may get requests from third-party clients using different API versions. So there's a need to handle multiple versions at the same time. So IIPImage is the most widely used IIIF server. It's been in active development since the late 1990s, so it predates IIIF by quite a while. It's included in many package managers for Linux distributions such as Debian-based systems, Fedora-based systems, making it relatively easy to install and maintain. And IIPImage supports all existing versions of the IIIF API, going back all the way to version 1. And it has full level 2 feature compliance, which is the highest level, and it's fully conformance validated using the IIIF validator tools. So how can we handle different API versions? Well, the version is determined using two methods within IIPImage. You can have a default version defined at startup, and you can override this for each individual request. So how do you set the default version? Well, by default, IIPImage sets the image API to version 2. However, you can set this at runtime to any other of the supported versions. So you can set something called the IIIF_version parameter. And as we can see here, we've set this here to version 3, that you can set this to whatever you want. So we can set an API version individually for a request using HTTP headers. These can be used by the client to ask for a specific version of the image API. If we have a look at this, this is another example from the IIIF.io website. It's a Stanford University's IIIF installation. These are the headers my Firefox navigator sends to the IIIF server being used. And the header we're interested in are the accept headers. And these allow the web browser to inform the server what kind of formats that are supported. We see, of course, that Firefox supports HTML, it supports XML, a couple of web image formats, and we can add a request for a specific IIIF version also. And the standard way to do this is using the IIIF._ protocol, like in this way. So we can see how this works. So I have installed on my local machine at localhost an instance of IIPImage using the default setting, so it's serving version 2 by default. If we use curl to request an info.json file for a particular image, we see something like this, and we can see from the context field that it's using sending back a version 2 JSON file, and we can see this more clearly from the profile section. If we now add an accept header with version 3 requested using curl to the very same URL, we can now see that we're getting back a version 3 API request, and we can see this more clearly by the much cleaner syntax at the bottom here for version 3 of the API. So handling multiple API versions through a single endpoint can create problems, especially for caching. Well, this can be solved by establishing different URL endpoints for different versions. For example, you could have /IIIF/2 for version 2, /IIIF/3 for version 3, etc. How would you do this? Well, you could start separate instances of IIPserve for each endpoint. If you want to have a single instance of IIPImage running, you can also use header injection to append the appropriate accept headers before forwarding this to IIPImage. So you can do this with Apache using mod header, etc., or nginx. So all these features are available in the latest development version on GitHub. It's been available for quite a while. We're going to have a full release early next year in 2023, version 1.2, which will have full API version 3 support for PNG and WebP output, HTJ2K detection and support. It's linked to one of the earlier talks in this online meeting. Speed and memory improvements, and many other enhancements and bug fixes related to IIIF, as well as features beyond IIIF, such as support for multi-dimensional image stacks. So for more information, please visit our website at iipimage.sourceforge.io or our GitHub page, or you can contact me directly. Thank you.
That's wonderful. Thank you, Ruven. Really great to see not just the support for both versions in IIPImage, but a little bit of discussion there about how to make that a little bit easier to help institutions make that transition. Let me get to the next video here. But this next lightning talk is from Petr Žabička from the Moravian Library, talking about IIIF Presentation 3.0 Gateway for the Kramerius Digital Library API.
Hi everyone, I am Petr Žabička from the Moravian Library in Brno, and I would like to present IIIF Gateway for the Kramerius Digital Library Systems. The application has been developed by my colleague Pavla Rychtářová and is already running as an online service for any Kramerius installation. First, let me tell you something about the digital library landscape in the Czech Republic. Libraries share common digitization standards set by the National Library, standards such as METS, MODS, ALTO, JPEG 2000 and so on. Most of the Czech digital libraries use Kramerius open source library system. Kramerius has over 50 installations. It's being used by the National Library, research and university libraries, as well as large regional libraries. Kramerius has been developed to be able to index hundreds of millions of pages, and a lot of effort went into making it user-friendly as well. For many years now, Kramerius has an open API, and its web interface is just an application written in Angular. The API let us build central services available to all Kramerius installations. One of these services, Registry of Kramerius Systems, gives us a detailed overview of the contents and status of each digital library. Information gathered from them is also available through an API. The registry simplifies development of Kramerius tools and gives libraries incentive to compete and digitize more. It's also very practical to know which versions of Kramerius are running where or for how long has been a given system offline. Kramerius is quite complex. On the backend, Solar Index is the most important part of the system. As most of the image files are in JPEG 2000 format, Kramerius includes IIPImage server to serve JPEG image tiles through IIIPImage API. All internal components are managed by Kramerius core system, which controls access rights and provides an open API to the internet. Through the API, Kramerius web client can give access to any Kramerius digital library. The web client can be configured to access several Kramerius systems from one place, as you can see on this screenshot. Unfortunately, users must choose one digital library and then search it. At the moment, they cannot search all Kramerius systems at once. In the near future, this problem should be solved by the Czech Digital Library Index, because the Czech Digital Library is currently undergoing extensive upgrades to help keep its index synchronized with the local Kramerius indexes. When searching, users have access to many search, sorting and filtering options, including a geographic search. Kramerius supports assigning various access licenses to documents, and the client can then treat each license type differently. Kramerius supports a large number of document types. In Kramerius 7, virtual collections have been added as a new document type. Collections have their own bibliographic descriptions and are treated as any other document type when searching. What is special about the collections is that they can contain any other document type, be it a page or another collection. To access the IIIF resources, user has to go to the document view and click on the metadata icon in the top right corner. The IIIF presentation manifest and its URL is displayed when the user selects IIIF in the top left menu and the correct document type. If page is selected, Kramerius returns the info.json from the IIIPImage API. As you can see, the presentation API URL is easy to create for their central web application. For other Kramerius client installations which are running on different servers, the information from the registry of Kramerius systems is necessary to build a consistent URL. The decision to build the gateway as an independent web service was based on the fact that many libraries do not update their systems very often, but they all provide the Kramerius API, so it's easy to update the service as often as necessary. It also helps long-term stability for the manifest URLs because they do not depend on the URL of the individual Kramerius installation. There is still work to be done. In this example, the photo of the spine of the manuscript was placed at the beginning of the book moving all the following pages by one and breaking the two-page display in the universal viewer. There were many challenges during the development. For instance, the manifest has to include the length of audio files, so we had to add a new field to the Solar index to have the information available. This only works in Kramerius 7, so for any older Kramerius installations, the length of any audio track is set to 1 second. The Mirador can cope with this, but Universal Viewer stops after playing the first 1 second of each track, so we'll probably have to extend the default length of the track. Unfortunately, we could not use this approach for canvas size. It would be extremely time-consuming to index the dimensions of all 70 million images we have in Kramerius, so we use the actual image sizes gathered from the Image API in real time, only for documents with 50 pages or less, and we use generic image size for the rest. With PDFs, we are creating fake manifests which contain just the metadata and a link to the PDF. Some libraries do not use image servers, so they do not provide IIIF Image API service, just thumbnails and full JPEG images. Anyway, we will be glad to hear your comments and suggestions. You can contact us through our GitHub issues or by email. Thank you.
Thank you, Petr. Excellent to see that update of that software tool, Kramerius, and I love that idea of being able, IIIF helping to enable some of that work, being able to connect elements across different check libraries. That's really part of the dream of IIIF and interoperability. Great. Well, up next, we have a lightning talk from Marcel Duin from Micrio, talking about WebAssembly and hypercharging IIIF implementations through the use of WebAssembly. Here we go.
Hi everyone, welcome to my lightning talk about WebAssembly and how it changed the way that we use it for our IIIF image delivery and viewing methods. My name is Marcel Duin. I'm the creator of the Micrio ultra-resolution storytelling and collection presentation service, which also uses and offers IIIF compatibility both as a client viewer and also the IIIF Image API as a auto-scaling server service. Both are powered by a thing called WebAssembly, which is what I'm going to talk about for the next 6 minutes and 15 seconds. First, a very short history. WebAssembly started in 2013 already as a technology to be able to run low-level code very close to the CPU in your browser. Back then, it was still used to be able to play high-quality 3D games in your browser using kind of the full power of your CPU. A few years later, 2017, this was picked up by the W3 Consortium, Mozilla, Apple, Google, and Microsoft, and it became an official browser standard already in 2017. So this is not a very new technology. And also more recently, it also grew to grow outside the browser. It kind of got its own life for use as a server platform, as microservices, and is also very usable for low-powered IoT devices. So what is WebAssembly? It is basically a compile target for a lot of different programming languages to a standard binary executable that is readable by your CPU and that can be executed on almost any platform. The cool thing is there are currently over 50 programming languages that you can use to compile to WebAssembly. A few examples of them are that have full support. That means to the browser for standalone binaries and for use in servers. It's C, C++, C#, Rust, Ruby, Go, Swift, Haskell. Also some partial support, which are still growing further, is Python. You can use COBOL even, R, Kotlin, Lua, and Perl. Very interesting. Did you know COBOL is already 63 years old? Swift is only 8 years old. So it really is up to the developer to choose their own development environment. So how did I use IIIF to empower our image service Micrio using IIIF? First of all, we used it for the CPU-heavy operations, and these are on two parts. First, of course, is the in-browser zoomable image viewer. You should be able to view very high-resolution images with 60 frames per second on older hardware on all phones, so it has to perform really, really well. And secondly, we run an image API service that also has to allow for high traffic and auto-scaling. So also on the server side, we use it. First off, the client, the petapixel viewer. Earlier this year, we presented a record-setting highest resolution ever scan of the Nightwatch by Rembrandt. The original pixel resolution of the image is 925,000 by 775,000. That's almost 1 petapixel. The total storage size was 4.5 terabytes. This is something that needed an optimization from our viewer client, which back then didn't use WebAssembly yet. So basically what we did is we created an engine which runs very close to the CPU, which manages all the downloading of the tiles, which tiles should be displayed in the screen, and also handles all user input like the panning and zooming and any camera animations. And it connects straight to WebGL, which is the graphical output that runs in your browser. The result was pretty awesome. The viewer for this petapixel image used only 4 kilobytes of memory, and every CPU cycle is fully under our control. And the binary engine file for this executable is only 24 kilobytes. So we kind of got a huge improvement for that. A bit later, this engine is still running perfectly, and it's already been 2 years now that it's being used by the Micrio client, and I'm very happy with it. Our next problem was the IIIF server. We support the IIIPImage API for our customers. We have some museum collections hosted that are getting more and more traffic. So as you can see on the left, we have almost 500,000 hits per day. Our two-server load balanced a single image API server couldn't handle that anymore. So basically what we did was we went back to basics, and this was a process of 9 months. So it took a little while, but now we have a very good solution. We actually wrote an IIIF image API implementation in C, so not C# or C++, that used the original JPEG and PNG source codes from the 1990s. It is running native in Cloudflare, which offers native support, and it basically functions now as a smart CDN that every hit is handled as locally as possible to the requester. So we basically have almost infinite scaling, and now 500,000 hits per day is no problem for us, and the latency is very, very, very low. This is my lightning talk about WebAssembly. It is a really exciting technology. Please Google about it, and there are a lot of resources that you can learn about it. It is still a very, very quickly growing technology in many different areas of applications. If you would like to read more about my two adventures, both for the viewer client and this IIIF image API, please follow these links. They are very detailed blog posts. And I still have 40 seconds, so thank you very much, and have a nice day.
Welcome.
Oops, sorry about that. Thank you, Marcel. Really lovely look into some really powerful work to get lots of performance out of IIIF implementations. And there's some comments in the chat about about kind of how effective that has been. Our next lightning talk, let me cue it up here, is a discussion about a little bit of community work. So there's a number of folks involved here. Glen Robson from the IIIF Consortium, as well as Stefano Cossu at Harvard, Ruven Pillay from IIPImage and C2RMF, as well as Michael Smith, who has been a consultant with Kakadu and has been really helpful in this process. So you'll hear them talk about a new version or a new encoding decoding mechanism for HTJ2K or JPEG 2000 called HTJ2K. And there's some really interesting work here about doing some performance analysis about the context where this might be the most useful to the IIIF community. So here we go.
Welcome all to the HTJ2K decoding and IIIF We're a group of volunteers from the IIIF community who are interested in seeing the results of testing this new image format. You can follow along with this work on the HTJ2K Slack channel and feel free to join future meetings. I'll pass over to Mike now to talk about H2J2K.
This test was focused on a new image format called High Throughput JPEG 2000, or HTJ2K for short. It's a new standard that was published in August 2019 by ISO and ITU, the same group that published the original JPEG 2000 standards. It's an enhancement to JPEG 2000 Part 1. It replaces a slow block coder with a fast one, but otherwise keeps everything else the same from JPEG 2001 Part 1, except for quality layers. And importantly, it maintains the royalty-free intent like JPEG 2000 Part 1, which is important for users and implementers. Because it's an enhancement to JPEG 2000 Part 1 and keeps everything else the same except for the block coder, it's possible to convert to and from JPEG 2000 Part 1 into and out of HTJ2K without any loss. And identical decoded imagery. Implementations available with both commercial and open source licensing terms.
In order to evaluate HTJ2K versus other formats, we set up some tools to measure both the encoding and the decoding. So we converted some source images to different formats using Kakadu, OpenJPEG, Grok, and VIPs via some bash scripts. Also, we set up an image server and a client to test the decoding. The image server was IIPImage in two flavors, one with Kakadu and the other OpenJPEG. Both were fronted by Nginx. And the testing client was Locust, which is a Python tool, and that was launched by command line. We also had some Python scripts to convert plot graphs from the results that Locust output. All these test tools are available now as Docker containers in the Git repository. Also, we didn't include encoding tests in this presentation because they were presented previously.
So this slide shows the file sizes that resulted from encoding in the different formats, both for lossy and lossless. The results show that PTIF is about twice as big as JP2 and HTJ2K, and the HTJ2K files are about 5% bigger than the JP2 files. The file size results were this same regardless of JP2 or HTJ2K encoding software that was used.
Tiles are central to how IIIF works. When you view an image like this example of the Mona Lisa, as you are zooming in, you're requesting tiles or small parts of the image as you zoom in. Your viewpoint in this diagram is the red box, and as you zoom in, you're sent different tiles as you're zooming in. You're only sent the tiles that you're looking at, which is the secret of how you can view very high quality images by only getting the requested tiles. These tile requests are the most common types of requests that a IIIF viewer will make. And I've got an example here of looking in Mirador, and as you're zooming in, it's only requesting certain tiles. And so part of our testing is looking at the amount of time it takes to request these tiles. For the testing, we created a list of IIIF URLs to different tiles and then sent the same request to the different image formats using the same IIPImage server. We then worked out the average request time to generate these graphs. You would expect PIRIMANTIF to perform well in these tests, as this format has the tiles as separate images encoded within the image itself. And indeed, this is the case for both lossless and lossy. H2J2K is considerably faster than JPEG 2000 Part 1, and Kakadu H2J2K is getting closer to PIRIMANTIF.
So apart from tile decoding, another set of tests we did was to decode whole regions. So an important use case for IIIF is extracting derivative images. So images at different sizes, such as thumbnails, medium-sized images, or large images. So here's a graph showing how the various codecs handle different image extraction sizes. So ranging from very small images at 128 pixels up to 500, 1000, and 4096 pixels in size. And as we can see, HTJ2K Kakadu performs extremely well as you go up in the size range and outperforms tiled PIRIMANTIF for the medium and large images. What we also notice is that HTJ2K remains faster compared to JPEG 2000 Part 1, and that Kakadu is considerably faster than OpenJPEG. So to conclude, one of the purposes of these tests was to evaluate HTJ2K and whether it was of interest to the IIIF community. In terms of performance, there's definitely an improved decoding speed compared to JPEG 2000 Part 1. It's 2 times faster for lossy decoding and about 20% faster for lossless decoding. In terms of maturity, HDJ2K is supported by the latest versions of both Kakadu and OpenJPEG, and IIIF servers such as IIPImage can already decode HDJ2K without any code modification, assuming that you install the latest Kakadu or OpenJPEG. There are, of course, some small disadvantages. HDJ2K file sizes are slightly larger than JPEG 2000 Part 1, and there are no quality layers included in HDJ2K. And this is only a temporary disadvantage. There's currently limited encoding support. Only Kakadu can create JPH files at the moment, but no doubt OpenJPEG will soon be able to do this. So if you're already using JPEG 2000, it's only worth considering adopting HDJ2K. Another category of conclusion is a more general one, looking at file formats and codecs in general. The test provided an opportunity to compare different JPEG 2000 codecs and to compare JPEG 2000 to TIFF. So these tests provide a useful benchmark for those choosing a file format for their repositories. There are, of course, trade-offs for each file format in terms of file size versus speed versus software support. And for our two use cases, for pan and zoom use, for example, when using Mirador, tiled pyramid TIFF has the fastest tile decoding speeds. However, for creating image derivatives at various sizes, HDJ2K was the fastest for medium and larger sizes. In terms of codecs, OpenJPEG remains, despite recent improvements, very slow with respect to Kakadu. Thank you.
That's great. Thank you so much to Ruven, Glen, Mike, Stefano for doing that work. I've seen it develop and iterate over the last few months, and it's really great to see the conclusions of that. And I think there'll be some publications related to those results as well, and we'll be publicizing those in the IIIF community. So we'll have the recording of this lightning talk also, but also look for some of the other outputs of those investigations. And Glen's just put in the chat. Thank you, Glen. The raw results in the GitHub repository where those Docker images and I think some of the other mechanisms are stored. Well, great. We're coming to the last lightning talk of this session. This is an update from Joe Song from IntelliJourney.com, talking about Etu 2.0, which is a tool that he's created and iterated on for the IIIF community. So we'll play this, and then we'll wrap it up right after this last lightning talk.
Hello everyone, my name is Joe Song. Today I'm happy to introduce Etu2, an open source local first IIIF tool. First of all, why local first? As you know, there's although there is now a lot of software in IIIF community, we have an awesome IIIF list, which give us IIIF server, IIIF viewer, or even manifest generators. But that's not the whole story. Actually, not every institution is capable of combine these software together. We need to provide a total solution. And also we need to make it happen on a local machine. It brings the benefits of let researchers enjoy more privacy and improve image processing performance during cases like AI, and also save money. The paradigm shift under the scene is like what is happening now in the Web3 world. We would like to decentralize all IIIF servers and let or empower those IIIF content producers to launch their own server to annotate their own images and to public their work by their own choice. Technically, E2 also improved a lot. Now you have 2 additional viewers, that is Mirror 2 and Mirror 3, and the Universal Viewer 4. You can now use annotation, which is provided by Mirror 2. In current version, you don't have any limitations for manifest now, which means you can bring several manifests in one viewers and compare them. We changed the image processor from GIMP to Sharp, which gave us a surprising boost in performance. We also support 5 more different image formats other than JPEG. They are all very good at limiting the size of image, especially AVIF. We separated the E2 process into 3 steps in this version. I'll show in next slide. As you can see on the left side, we first initiate a new folder by providing all the necessary parameters. We provide a path for the image. And then we use the install command, which converts these images to the target format. Now we can launch it. As you can see, it's in less than 1 second. We launch it. It's super fast. Okay, what's next? Well, in our next version, we plan to integrate IIIF servers like IIP, Cantaloupe, or SciPy, or all locally inside the E2 command, inside the E2 environment. Also, we would like to coordinate with institutions to publish local assets to existing IIIF hosting servers. Last, we would like to improve the connector to local annotation servers. So, if you feel our work valuable, please try it and give us stars. Thank you.
Excellent. Thank you, Joe, for that lightning talk. And thank you to everyone who presented today and in the previous lightning talk. round, that is the conclusion of the lightning talks that we have for this online meeting. We do these very regularly. It's a very popular thing in the IIIF community. So we'll be featuring more for sure at our annual conference in June, but look out for calls in between then and now. The community groups often will do calls and showcases of relevant work. So that concludes both the lightning talk session here and now, but also the events that we have for today. The IIIF online meeting continues for one more day tomorrow. So we have sessions about the museums community group, the maps community group, and some presentation of strategic planning on behalf of the executive committee in IIIF. So we're gonna call it there for now, but please continue the conversation on the IIIF Slack channel, and we'll see you tomorrow when we start up again. Thank you all for your attention and have a great day.
Thanks, IIIF staff. That was great.